Hello everyone, how's it going? My name is Dan the Tutor. Today we're going to talk about Lesson 8 of the Geometry Summer Course. We're going to be talking about circles today. This is the 8th and final week of the Geometry Summer Course. So after today I'm going to give you the homework, the final homework, and then I will be done with you and you are free to go. I hope you learned a lot this summer. So today we're going to end on a good one. Basically everything is better than proofs from weeks 5 and 6, so this is going to be easy by comparison. So when it comes to circles, we're going to mainly talk about two concepts, and that's area and circumference. Things that you've probably learned in grade school, and I can promise you about 100% of my college students don't know either of these equations. Very sad. Anyways, circumference is the perimeter of a circle. So in other words, the outside. And then area is obviously the inside of a circle. This is going to be the easiest fill in the blank, at least for the summer, I think. So circumference is the outside, area is the inside, and now let's talk about the equations for circumference and area. And that is circumference, I usually call it C. C is equal to 2 pi r, 2 pi times the radius. And then the area A is equal to pi r squared. Very important that you memorize these two. And by the way, the units for circumference and area are very distinct. In other words, the units for circumference are inches, sometimes it's centimeters, sometimes it's feet. But notice the units are not squared. As opposed to area, which would be inches squared, centimeters squared, feet squared. Whatever the unit is, it's squared for area and not squared for circumference. And one more thing I do want to say, if you are ever given a diameter, just remember that diameter is equal to 2r. It's twice the radius. And so, you probably knew that already, but that also means it's going to affect my circumference and area equations. If you want my advice, just find the radius if they give you the diameter, and then you can plug in the equations I have in front of you. And then you only have to memorize two equations. So as an example, number 1, find the area and circumference in terms of pi. And when I say in terms of pi, I mean don't plug in 3.14 in your calculator. Don't plug in pi in your calculator. Just leave the answer with pi in it. I'll show you an example with the first one. So find the area and circumference in terms of pi of a circle with a diameter of 4 centimeters. Very first thing I'm going to say, the radius r is 4/2, which is 2 centimeters. And so then, now, I'm going to say area is equal to pi r squared. So in other words, pi times 2 squared. And that's going to be 4 pi for the area. Notice I'm writing my answer as 4 pi. I'm not plugging in pi in my calculator. I don't need to. And the units are going to be centimeters squared. Because for area, the units are centimeters squared. So there we go. There's my area. And now for the circumference, I'm going to say C equals 2 pi r. So C equals 2 pi times radius 2. And that's also going to give me 4 pi. What a coincidence. But the difference is the units. The units are not centimeters squared. It's just centimeters because circumference always has units of centimeters. Any questions on that one?
You're kind of rushing.
Okay, sorry, I'll slow down. I knew you say that every week, and every week I try and go slow, but clearly, obviously I'm writing faster than you, so thank you for letting me know. So, I'm going to continue on. For the next problem, it's actually a fun one. How much more pizza is there in a 16-inch pizza than a 14-inch pizza? And so, when I say how much, I'm saying the area. In other words, how much bigger is the area of a 16-inch versus a 14-inch pizza? One thing you ought to know, that when I say 16-inch and 14-inch, is that the diameter or the radius? That's the diameter. And so in other words, I got to find the radius for these two. Like for instance, the radius for the 16-inch is just 8-inch, and the radius for the 14-inch is just 7-inch. And once you have that, area is easy. Because area for the 16-inch is going to be pi r squared, where radius is 8. We're going to square that. So then I get area is equal to 8 squared 64. So it's 64 pi. That's my first area. Now how big is that in terms of area? I have no idea. Even if I were to plug in pi and I get some number over 100 probably, I still wouldn't know exactly what that means for the area. But we're comparing it to the 14-inch, so hold on. It's 64 pi, perfect answer. Oh, and the units are inches squared. And then for the area of the 7-inch, all I'm going to say is pi times 7 squared. 7 squared is 49, so the area is 49 pi inches squared. And so once I have my two areas, I can now compare them. Obviously 64 is more than 49 pi, but how much more? Well, I'll tell you, it's 30% more, approximately. It's approximately 30% more. And in case you're curious how I did the math on that, it's not important because it's not really what the question's asking. The question, you can stop by, well, I guess you should subtract these two quantities, right? So what I'm saying is 64 pi minus 49 pi, that's going to be, what, 15 pi? Yeah. 15 pi is going to be how much more pizza I have in the 16-inch than the 14-inch. And the way I got 30% more, approximately, is I took that 15 pi, my answer that I just said, and I just divided it by the 14-inch pizza, which was 49 pi, multiply by 100, and you'll get about 30% if you do that.
Wait, repeat again. I didn't hear you.
Yeah, absolutely. So I take this 15 pi, which, where did I get that number from? It was the 64 minus the 49 pi. So it's the difference over the total. And I chose the smaller number. Why? Because I want to see how much more it is than the 49 pi. If I want to see how much less it is, I would have chose the bigger number in the denominator. But I want to see how much more pizza it is, so I choose the denominator. And I'll get 30% more pizza, which is significantly more pizza. So if you ever see a 16-inch versus a 14-inch at the pizza parlor, basically what I would tell you is the 16-inch is significantly a better deal. Because you get 30% more pizza, and it's probably only like $1 or $2 more. Any questions there?
No.
Okay. Then moving on, we got a pretty tough one for number 3. If the circumference of a circle is 12 pi feet, what is its area? So notice I'm giving you circumference. I tell you it's 12 pi, and I want to find the area. Anyone have an idea of how I'm going to find that? So I would say a good idea. Go ahead.
Multiple, right? You said like multiply the variable times the number.
What variable and what number?
Like you said 12 feet times something.
Not quite. Not quite. Let me explain. First, we have an equation for circumference, right? Circumference is 2 pi r. So I can say 12 pi equals 2 pi r. And then notice, I don't know the radius right now. I can find the radius if I just divide both sides by 2 pi. You could even say the pi cancels. And so therefore the radius is 6. 6 feet.
How'd you do that? Why do we have to write so many pi symbols everywhere?
I have a feeling the second question was a rhetorical question. I'm going to answer your first question. The reason why this is true is because the circumference was 12 pi, and the equation for circumference is 2 pi r. And we don't know the radius, but if you divide both sides by 2 pi, you got r by itself. And 12 over 2 is 6. So now, once you have the radius, now you can easily find the area, because area is pi r squared. And so just plug in 6 for r. Area equals pi times 6 squared. And so you'll get 36 pi. Oh, and the units are feet squared, because it's an area. Any questions there? I guess I forgot to mention pi is a decimal 3.14. I'll write that down here. Pi equals 3.14. And if you want to know where that number comes from, it is the number of diameters that can fit in the circumference of a circle, which is basically where we get the circumference equation from. Now, if you don't know what I mean by that, don't worry, just memorize 3.14. That's all I care about. Oh, and as you know, pi is a decimal that goes on forever. I remember I competed in my Pi Day competition in 6th grade, and I lost. for lack of a better term. But then later in my career, when I became an engineer at engineering company, basically they had a pie eating contest one day for Pi Day, and then I won that. So I redeemed myself. So anyways, with circles and angles, first we want to talk about how many degrees are in a circle. And the answer is, of course, 360 degrees.
360.
I spoke too soon. Do you know what the answer is in radians?
You mean radians?
I mean radians, something that I just realized you've never heard of, and I'm thinking of my pre-calculus students, so don't answer that question. 360 degrees, that's how many degrees are in a circle. Then we have arc length. Let me show you something. Arc length is like circumference, but just for a portion of the circle. So you see the black bolded section right here? That's arc length. And obviously, go ahead. What'd you say?
How many degrees is it? 45 degrees?
Oh, this angle I just made up? You're talking about the angle I just made up, right?
Yeah.
Yeah, it doesn't matter. Like, I'll call it theta, because theta can be any angle. Could be 45, could be 50, doesn't matter. But regardless, the arc length here is going to be, well, we're going to find a few different ways of calculating the arc length, but you can measure it in two ways. One, you can measure that arc length in degrees out of 360, right? And then the other way you can measure arc length is as an actual distance, like for instance 10 centimeters or something like that. Today we're going to be doing both. We're going to be representing arc length in both degrees and like a distance. And if you want to know how, well, that's what we're going to do on the next page. So on the next page, we're going to talk about three kinds of angles. The first one is the central angles. Central angles is because it's the center of the circle. It's the center of the circle. The secret to central angles is that if that angle's 30 degrees, then the arc length is 30 degrees. So that's the arc length in degrees. But if you want to find arc length as a distance, which I'm sure we do, because I ask a bunch of questions about it later, then we need to use this equation. L over 2 pi r equals theta over 360, where L is your arc length as a distance. L is your arc length as a distance, and theta is the degrees of your arc length. So in this example, 30. Now I'm not going to solve for the arc length here in this problem. The reason why is because I can't. Why not? Do I have a radius? No, so I can't find the arc length. But this is the formula we're going to use, and I highly recommend memorizing this equation because let me tell you something, I tutor SAT as well, and this shows up on the SAT most years. So it's helpful to know this equation. Next, we have the inscribed angle. An inscribed angle is simply an angle that starts from the edge of the circle. As you can see here, the central angle started from the middle. The inscribed angle starts from the edge of the circle and then goes, well, to the other edge of the circle. And the secret is if you want to find the arc length in degrees, that is, then, in other words, you want to solve for x, then x is going to be 2 times your inscribed angle. 2 times your inscribed angle. So can someone tell me what x is going to be for this example?
40.
Yes, exactly. You just double it. That's exactly right. Okay, good. And by the way, that equation I said earlier, the L over 2 pi r equals theta over 360, that's still going to hold true for the arc length as a distance. Just remember that theta is not the 20 degrees, it's the 40 degrees because it's always the arc length angle. Any questions there? Okay, good. And then the last example you can have is the intersecting chords. And intersecting chords basically look like this. It just has two lines intersecting. And what are these two angles called that we learned in like lesson 1 or lesson 2?
Vertical angles.
Very good. I remember you asked what are vertical angles and you were having trouble with vertical angles in like lesson 3 or 4. But I'm glad you finally figured it out. So, good. Now, x, the vertical angles in the middle, is equal to a plus b over 2. That's it. So if I have a and b, I can find x. Sometimes x is on the outside, but you still follow this formula. It's the two outside angles added together divided by 2 is the inside angles. And by the way, another word for this, this is the formula for an average. So it's the average of A and B is another way of saying that. Any questions?
What do you mean by average?
I mean, do you know, like, if I ask you, take the average of these numbers, 30 and 50, take the average of these numbers, or the mean, how would you do it?
Add them up and divide by 2.
That's exactly what I just said. Yes. So, it's the average.
Oh, it's the mean.
Yes. If you want to write mean, you can do that as well. Any questions?
No.
Excellent. Then for the rest of the day, we're just going to be looking at examples. Honestly, pretty short lesson today. You guys got lucky because next year it will not be this short. But that's okay. So for number 4, or really for the rest of these, it goes all the way to part F. We are given the angle. I want you to find the measure of the arc length in both degrees and as a length. So for part A, what kind of angle is this? Is it a central angle, inscribed angle, or intersecting chords?
That looks like an inscribed angle.
Definitely central, because it's in the middle. Yeah. Remember, inscribed is going to look like this. That's inscribed, because it's touching the edge. But because the angle's in the middle, it's a central angle, which means the angle here, 155, is the same as the angle for my arc length, 155. So there's go ahead.
So this means we would have to do 72 over 2 pi r?
Yeah, so 72 is the radius. I want to be clear about that. It's not so obvious there, but 72 is the radius. So I'm going to be plugging in the equation L over 2 pi r, where r is 72, equals the degrees for theta is 155 divided by 360. And now if I want to solve this, I'm going to have to cross multiply. And this is where you're going to need a calculator for today. But here's what I get. I'm going to get 360L on the left side, and on the right side, 2 times 72 times 155 gives me 22,320 still times pi. I'm still leaving my answer in terms of pi. And then if I want to solve for L, all I got to do is divide both sides by 360. And I'm going to get L equals 62 pi as my final answer. I don't have any units for these. The units aren't important anymore. You get it. But are there any questions on that first one?
Wait, how'd you get 62? And a calculator?
Yeah, calculator. Okay, I'm going to move. Go ahead.
Nothing.
Okay. Okay, next is part B. We have a 60-degree angle right here. Again, it's a central angle. So hopefully you realize immediately this is 60 degrees right there. And again, I got to find the arc length. So I set up that proportion, L over 2 pi r. Looks like the radius is 12 this time. So 2 pi times 12. And then on the right side, I'm going to have the angle, 60 degrees, divided by 360 degrees. And if you want to, you can actually reduce this by cutting this down to a 1 and this down to a 6. And if you do that and you cross multiply, go ahead.
Why don't you reduce it to a 1 to a 6?
Let me explain.
Oh, because 60 divided by 60 equals 1.
Yes, they're both divisible by 60. I should have explained that better. Yes. And now when I cross multiply, it's pretty easy actually. It's going to be on the left 6L, on the right 24 pi. And then you just have to divide by 6. And we get a nice clean answer of 4 pi. Again, I don't care about the units. But I'm assuming, even though I didn't calculate it, I'm assuming the circumference, of course, is going to be more than 4 pi. Because circumference is like the total outside, while the arc length is just a portion of it. So although I don't know what the total is, I know it's going to be more than 4 pi. Any questions?
Wait, so we have to find the sum?
No, I'm not asking that. I'm just saying in general, as a fun fact.
Will we do it in the future?
You can. I mean, we already found circumference today, and this circumference is not hard to find. It would just be 2 pi r, and the radius is 12. So you'd get 24 pi as your circumference. But again, I don't care about that. Now, a challenge problem, and again, I'm not asking for this, but a challenge problem would be to say, hey, this right here we just said is 4 pi. The total is 24 pi. What is the red arc length? In other words, everything else. It would be 24 minus 4 pi. In other words, the red is 20 pi. And that could very well be an SAT question. Any questions on that one?
So it's like we're subtracting instead of adding?
Yeah.
Adding.
Oh, it is. Let me be very clear. What I'm asking two different questions. When I was adding them, first of all, I don't think I was ever adding them. I was setting up the proportion, which is not technically adding. That's a lot of multiplication and division. But the reason why I'm subtracting is like this. If I have 8 slices of pizza, I love pizza as an example, especially with circles. If I have 8 slices of pizza and I eat 1, I have 7 left. I'm using that same exact logic. And again, technically, the question's not even asking for that. I'm just saying it as like an extra way of going to the next step of what they could ask in your geometry class next year. So anyways, with the next one, radius equals 3. What kind of angle is this?
This is the inscribable angle.
Yes, this is the inscribed angle. Which means if that's 76, what's the arc length going to be? Whatever 76 times 2 is, which who can possibly calculate that? It's going to be 152 degrees.
Degrees, yeah.
And now that you have the arc length in degrees, well, now I can say L over 2 pi r, where the radius is, I say it here, I don't say it in the circle, the radius is 3, equals 152 degrees. Again, I need to use 152, cannot use 76, divided by 360.
Hold up, why can't you use 76?
I can't use 76 because that's not the arc length of the circle. I need the arc length of the circle. 76 is the inscribed angle, which is nice to have, but useless to me on its own. Does that make sense?
Yes.
Okay, great. Now all I gotta do is cross multiply here. And again, I plug these numbers in the calculator already. On the left side, I get 360L. And on the right side, I get 912 pi. And then I just got to divide both sides by 360. And this I just got a fraction for. Like I didn't get like a decimal. Although, if you want a decimal, you can write a decimal. Basically, I got a final answer of 15 pi over 38. And by the way, I use a TI-84 graphing calculator. And the way you convert your answer, because I got a decimal at first, but then I converted it to a fraction by hitting the buttons math and then 1, and like the first option is like reduced to a fraction or decimal to fraction. So that's what I did. The math button on the left, right below the alpha button, and then I hit the first option. And by the way, I did not plug in pi, because I keep telling you, I do not plug in pi at all. I just insert it at the very end because I don't want to deal with that. If you do put a pi in your calculator, you'll never get a fraction. Trust me. So that's it for that
Right,
one.
because pi is
Go ahead.
decimal.
Yeah, pi is an infinitely long decimal too.
How much long is it?
Literally, when I say infinite, it goes on forever. They have supercomputers trying to find the end of pi. It can't do it. So it's a long time. So next one, part D. This is obviously the only one left, the intersecting chords. I start off with 100 degrees, here's 80 degrees, and I want x. Hopefully you know what this angle is on the right. What is it? Not x, but the other angle here, the vertical angle.
80 degrees.
Yes, it's 80 degrees because they're equal. And now I'm going to use that formula I said earlier. A plus b over 2 equals x. But this is confusing because x is actually b. Let me explain. 100 is a, x is b, and then my two 80s are going to be my other, well, x from the earlier equation I said. So in other words, I'm saying 100 plus b over 2 equals 80. Because this x is 80. That's how the formula works. So if I want to solve for b, first thing I got to do is get rid of that 2 in the denominator. And if I want to get rid of that 2 in the denominator, I'm going to have to multiply both equations by 2. So I end up getting 100 plus b equals 80 times 2, which is 160. And then I just subtract 100 from both sides. The angle b is 60 degrees. And there we go. Any questions on that one? Okay, good. And now again, I still want to find the arc length. The arc length of that is going to be L over 2 pi r, radius is 10, and that's equal to 60 degrees over 360. And again, both of these numbers are divisible by 60, so 1 in the numerator, 6 in the denominator. And now if I cross multiply, on the left I have 6L, and on the right I have 20 pi. And if I want to reduce this, in other words, solve for L by dividing both sides by 6, and I reduce it, I get 10 pi over 3, and that's my final answer. And only 2 problems left, and then we're done for the summer. Part E, radius is 40, and it looks like I have an inscribed angle. So in other words, I got to find the arc length right there, and I'm going to do that by doubling the angle. Right? So 25 times 2, that's 50 degrees. And so that means, well, first of all, there's my answer for the arc length. And then if I actually want to find the arc length, I'm going to do L over 2 pi r, radius is 40, it says it at the top, equals 50 over 360. Again, I'm going to cross multiply. Looks like 360L equals, I plug in 2 times 40 times 50 in my calculator. I'm going to get 4,000 pi. And then I just divide both sides by 360. And once again, I get a fraction. But L is going to be 100 pi divided by 9. And there we go. There's my arc length. So just a quick recap on what we've done so far. The central angle, always the same. Inscribed angle, double. Intersecting chord uses the weird formula a plus b over 2 equals x. But any questions?
Oh, sorry.
Go ahead.
How was the last problem that easy?
How is the last problem that easy? Which one are you saying? Part F or part E?
Part E.
It's easy because inscribed angles are the second easiest case. Let me tell you, in order of easiest to hardest, central angles are the easiest because they're the same, exactly. Then it's inscribed angles because you just got to double it. And then the hardest is intersecting chords because you have a complicated formula.
Oh.
And with that, we go to part F, which is, of course, an intersecting chord. But don't worry, it's not a proof, so it can't be that hard. Anyways, I would say that the vertical angles here, 18 and 18, that must be 18 degrees. And then when I plug in my formula, it's going to be 8 plus x over 2 equals the center angle, 18. And that's not really a center angle in the sense that it's not in the center, but it's in the middle of the circle. That's what I'm trying to say. Anyways, if I want to solve for x, again, we've done this before. I got to multiply both sides by 2 to cancel out the 2 in the denominator. So in other words, 8 plus x equals 18 times 2, which is 36. And then I just subtract 8 from both sides. Looks like my angle is 28 degrees. So there's my angle, but now I still got to find my arc length. And to do that, I'm going to say L over 2 pi r. Radius was 16, so 2 pi 16 equals 28 degrees, the angle, divided by 360. And now for the final time today, I'm just going to cross multiply here. I'm going to get 360L is equal to 2 times 16 times 28 in my calculator is 896 pi. And then I just divide by 360, and I get a final answer of 112 pi divided by 45. And don't go yet. I still have one final message to give you. But first I'm going to let you finish writing. And the last thing I want to say, the message I want to leave you with this summer is, remember, I was doing all of these free summer courses for free. Normally, my tutoring rate is $60 an hour for high schoolers and even $80 an hour for college students. So that really begs the question, why on earth am I doing this for free? Why did I spend all this time, not just in geometry, 8 weeks in geometry, also another 8 weeks in Algebra 1, Algebra 2, Calculus, and Pre-Calculus, and Physics? It's because I want to be the best, the greatest in the world, the greatest of all time. And I want to do it by bringing the most value to my students, even if I get nothing in return. Because the truth is, that's how I started. Back in 2020, in the summer of 2020, when I first started tutoring, literally no one knew who I was. No teachers, no schools would ever reply to my emails. I was literally working for free because that was the only kind of work I could get. And it wasn't until 3 months later in the fall that I had my first paying customer. And by the end of that year, by the end of spring of 2021, the fall and spring semesters, I had 30 paying customers, and honestly, I made thousands of dollars, and it made it all worth it in the end. But honestly, the lesson to be learned is I don't do this for the money. I do this because I want to leave a legacy behind. I want to help people, and I want to become big. I want Dan the Tutor to help as many people as possible. So if you did enjoy my tutoring this summer, first of all, thank you for participating. And second of all, if you ever are looking for tutoring, I'd love to help you out. Or even if you know someone who's looking for a tutor, please tell them about the greatest tutor in the world, Dan the Tutor. So thank you all for coming to these lessons. I hope you have a great rest of your summer, and best of luck in the fall. Take care, and bye-bye.